So was it me or you, Cecil?
I thought I won. Didn't I win?
You won.
Also,
so I thought that meant you were going to do it. Or...
Oh, I'm sorry. All right. Hi, folks. Welcome to the .NET Doc Show. Now I got to go find the script.
Welcome to 60 minutes of obviously unscripted and, as our friend David Pine would say, unprofessional .NET entertainment. As doctors of .NET, we prescribe healthy choices in .NET. However, I should warn you that 9 out of 10 doctors agree we aren't actual doctors. I'm your host, Cam Soper, with co-hosts Cecil Phillip and Luis Quintanilla, and we'd like to welcome today's guest, Koen. Koen, please introduce yourself.
Hello, I'm Koen. I've been developing the .NET space for more than 15 years, and today I'm just going to talk to you about unit testing with Blazor.
Awesome. So along that vein, I think we have a checkup doc about testing in Blazor. Let's hit it.
All right. So for our checkup this week, we have this article called Test Components in ASP.NET Core Blazor. Now, there's different ways that you can go ahead and test components in Blazor, but typically the process that testing these components involves is you usually create some sort of input, some sort of test input, fake data even, to provide to your component for it to be populated with. Then you go ahead and potentially render and then try to interact, depending on the type of testing that you're doing, try to interact with that component. And then once some action has been taken on that component, you go ahead and inspect it and you evaluate it to make sure that you're getting the appropriate or the expected output from that. Now, there's two types of testing. One of them is unit testing and the other one is end-to-end testing. As the name sort of imply a little bit, here unit testing is a little bit more compartmentalized to like individual units of your application, whereas end-to-end testing that involves potentially looking at entire scenarios. So, for example, filling out a form and going through an entire user flow, and making sure that whole experience actually works. And Koen here is going to be talking to us a little bit more about unit testing here. One of the libraries that you could potentially use for unit testing is bunit. And if you're running end-to-end tests, you can use something like Selenium, perhaps, to perform your test. Now, depending on what your tests look like, you have some comparisons here in terms of what exactly is it that you're going to be testing, right? So, for example, for unit testing, you're only testing those C# components, whereas with end-to-end testing, you might be testing some of the UI elements that are part of your application, right? This table here as well tries to help you, depending on which scenario you're trying to test, right? Which testing approach is the one that's most recommended. So again, if you're only testing those C# components and some of the logic of your application, right, unit testing may be more appropriate for that. But if you're testing something that's a little bit more complex, maybe you're also trying out some of the JavaScript components, because remember, although you're writing a lot of code with Blazor and C# and .NET, there are still some parts that you might need JavaScript for. Now, in some of those cases, you might need either to unit test the C# components and the JavaScript components separately, or perhaps you may consider something like end-to-end testing for those types of scenarios, right? Especially if they involve working with the DOM in the browser. This section here kind of walks you through how you can leverage and use bunit, right, and the bunit library for your testing purposes, and how you might integrate it into your existing project and your workflows, right? And in case you're looking for additional resources, there's this getting started guide for how you can get started with bunit. So that's this week's doc. With that, let's actually see it in action.
Awesome. I am not Johnny on the spot with the camera changes today.
You know, I really love that music. I don't know how many times I feel like I come on the show and I say it, but I love like that little music we have. Like it's like the most upbeat thing ever.
Mm-hmm. I'm only here for the music.
So
Exactly.
just so we're clear, that music isn't mine. The countdown music is mine. That music, I'm not sure where we got that. That's probably stock.
Yeah, I love it, man. That's awesome. So what do we start talking about testing in Blazor? What do we kind of dig into it?
Yeah, Koen, what do you have for us?
I got something I hope you will like. First of all, I saw you talk about the docs just now, and those docs have been great for me for the last week. While I was working out this demo, I've been going through those docs, and I've been going over them, and I've used them to implement the basic testing scenarios that I have for this application. I went one step further, and I introduced some of my own packages on top of it, so which I call scenario test, and I will introduce you that in a second. However, perhaps let's first take a look at the demo that I prepared for today. So I told you before that I've been using .NET for like 15 years. Before I started developing and programming, I used to play a lot of video games. I consider myself a pro gamer, which of course I wasn't, but nonetheless, you're young. And I used to play a lot of Unreal tournaments. And I noticed over the years that I have not been playing games anymore, and my aim, as they call it, has gotten sloppy. So I created myself a little game. And this game, well, we can say play. I got a warm-up stage. And now my mission is to shoot the cat. Let's see how fast I can shoot the cat.
That's
of course,
horrible.
no animals are getting hurt here. It's just...
I think
and I was able to shoot the cat 9 times, which is, well, not particularly
Can we pretend we're petting the cat?
Sure thing. Let's pet the cat. Let's try it again. So I'm going to pet the cat, pet the cat, pet the cat. I'm going to miss a few times. I'm going to try again. And this time, still got 10 pets, 10 hits, and 2 misses, so my accuracy is 38%. That's 83%. That's not particularly impressive, right? This is, but that's beside the point. This is the demo app that I prepared for you for today. What I wanted to show you is this app has basically 4 states. So if I refresh the game, sorry, let me just run this. The great thing about Blazor, it is running offline. So even if the web server is not running, I can still play the game. So I got my initial state over here of the game. The moment that I press play, I move into this warm-up state, where there's a little countdown where I have time to prepare. Then now in my playing state, I can play around, I can click the cat, or I can miss the cat. And finally, we transition over into the final state, or the finished state. Right? So there are 4 states in this application. Indeed. If I look at the source code, and I kept this as simple as possible, so I just have one component in my application. By the way, do I need to zoom in? Is this big enough?
I would say zoom in just a little bit for folks.
Let's go to 50.
Yeah, that'd be good.
Better? All right, great.
Mm-hmm.
So I got a single component application here, which is just my root component. And in this page, I have, so let me just go to the code first. So I got a few settings that are just defaults. We don't need to configure them in our application, but we can configure them when we start to do unit testing. So I got my warm-up time. So remember, there's a 3-second countdown before the game starts. That's configured here. I got my game time. How long does my game last? Which happens to be 10 seconds by default. And I got my progress interval, which is just a simple timestamp, a time span that tells me that every 100 seconds, we're going to reevaluate if we should transition to the next state. Right? That's how it's implemented. I got the 4 states. So I got my initial state, my starting state, my started state, and finally my finished state. And then based on the current state of the game, I'm just rendering a little bit of a different UI. So my initial state says ready, set, and play. Right? And then when we transition to the starting state, we just tell you like we're starting in, and then the number of seconds remaining before we start the game. Finally, if we have our started state, we print out the image of the cat, and we give it the position where it should be at the moment. And we also record hits, and we record misses on this thing. And then finally, in our finished state, we just show you how many hits you have, how many misses you have, and what your accuracy is. And finally, we let you restart the game, so we let you go to the start new game method, which basically resets the game. Hits and misses will be 0. We're going to randomly position the cat on the screen somewhere, and we're going to transition to the starting state, which is like this warm-up phase that we have. And finally, we set like the next state to be the current date plus those 3 seconds that we had initially, right? So now we can count down 3, 2, 1, and then start the game. When this is happening, we have a timer that sits in a loop that just checks every 10th of a second to see should we progress the game to the next state. So we got this date time that says when we should progress to the next state. That is from the starting state to the starter state, and from the starter state to the finish state, which is what we're doing over here. And finally, from the starter state to the finish state over here. And then finally, we have a few helper methods, which is update target, which will randomly place a cat on a new position on the screen. We got a record hit method that records when you actually hit the cat or pet the cat. And we got a record miss method that records when you actually miss the cat. So this has a little guard in it that if the game has not been started yet, then you can't actually do anything. Like we're not gonna record hits when we are not in the starter state yet, right? So we have a little bit of safekeeping here to make sure that we can cheat by already start to attempt to hit the cat in the warm-up stage. So basically, this is, I think, the demo that we have. As you can see, the application is only 150 lines. It's not complicated, but it's also not trivial, right? There are 4 states. Each state has a few limitations to it. Like, for example, hits and misses can only be recorded when it's in the started phase, for example. So how do we go about and test this? I think to start with, let's just do a new test project. So I'm just going to use Visual Studio to create a new XUnit project. And this may be a little bit small to see, but just bear with me for a second.
Yeah, I know it's usually, that's the one thing about Visual Studio, right? It's hard to zoom into like the control boxes and stuff. But I think we could just talk through, folks, what you're doing, right? So you went through the templates, you selected a new NUnit project, and now it's just kind of scaffolded out this new thing inside of your solution, pretty much.
Yeah, this is XUnit project. So you got the basic new unit testing project in XUnit. Now we mentioned earlier that we really want to do, we want to include BUnit here. So we're going to do unit testing here. So this is the Blazor project, so we really want to have BUnit.
Got it. And then so for some folks that, I know some folks may or may not be familiar with BUnit, but really quickly, is BUnit like a testing framework that we could use alongside any other testing framework, like kind of use it next to MS Tests and NUnit and XUnit like you're using right now, and it's just specifically for Blazor?
Yes, BUnit is just adding some sweet sauce on top of XUnit to make sure that we can interact with our components in an easy way.
Got it.
So it's super useful. So now let's implement the first test, and let me just get a little sneak peek here. So let's start with this part. The test context here is coming from BUnit, and this gives me context in which I can render my Blazor components. So if I just add a reference to my application over here, and start to use this, you can see that I'm changing the settings of an app, the warm-up time and the game-up time to just be 1 second. This just speeds up our unit test. There's no need to spend 3 seconds or 5 seconds or 10 seconds to wait for the game to finish. Well, what will I do then? Like, okay, you got my basic scenario set up. My test is called test 1. What will I do next? Well, let's implement a scenario. Let's implement a happy path. So let me just call this a happy path. What's going in a happy path? Well, first of all, we're going to start a new game. Okay. So then let's try something. So we were in the initial state, and now we started a new game. Let's try to record a hit and record a miss. Okay. Now let's sleep for a little while. So while I'm doing this, I am waiting for the app to transition to the next phase. So this is warm-up time, and I'm giving it a little bit of overhead because, again, every 10th of a second, we actually check if we should progress to the new state. So I'm just going to wait for like 1.5 seconds, and then I am going to record another hit and a miss. And then finally, I'm going to sleep again. And this time I'm going to wait for the game time. So again, the game usually lasts for 10 seconds. So if this was 10 seconds, then I'm just going to sleep for 10.5 seconds, just to make sure that they had time to transition to the finish state. So I have a scenario here, which is the happy pet. This is not a great example of how to do unit testing, but it's useful because right now I can just attach a debug to this. I can say debug test. And lo and behold, I should be able, if it builds, to manually test my application. So if I just go to this, I have my app, I give my configuration, and I can look at the instance and I can say my state is the initial state. Again, this doesn't really scale well with Visual Studio, so it may be hard to see for you, but the state currently is initial. I go to start a new game. Again, I'm in a debugger, so this is already adding time. I can look at my app, and at this stage, it's already in the starter state, right? Because I'm in a debug, I'm holding my app captive, and my app is just running in the background. So my scenario here and my what I was expecting are now incorrect. So if I just put a breakpoint here and I debug this again, I can now see that, hey, my instance, I have 1 hit and 1 miss, right? Even though I record hit twice over here and over here, I only recorded 1, right? Because again, the app was not in the starter state until over here, over this section. So this is very primitive. This is not really unit testing. This is just primitive, basic manual testing, but it works. It's good to test out your application this way. But of course, this is not what we want. So please note that this is a very useful way of testing the application because, you can just see your happy pet, you can see your scenario in a bunch of lines of code.
So Koen, let me jump in real quick because we have several questions that have kind of piled up that we should address.
Go ahead.
The first one that came in is back when you selected your testing framework. Why XUnit? Why not like MS Test or NUnit?
There are many opinions on this. I personally like MS Test. I also like NUnit. I'm actually pretty happy with MS Test these days. XUnit, however, still has like a special place in my heart because it has certain features that I've been using over time that I just got accustomed to. The real reason why we're using XUnit in this case is because later on in this presentation, I'm going to introduce scenario tests. And scenario tests at the moment are only compatible with XUnit. So it's a
Gotcha.
method of convenience. Yes, but BUnit will be compatible with MS Test, will be compatible with NUnit or XUnit. So BUnit is compatible with all of this. So you can do this with any testing framework these days that are popular in .NET.
Well, on that subject then, so BUnit tests, they're run headless, correct? That's like running the Blazor component like on a string, right?
Right.
Gotcha. Okay. Now, in the actual test that you wrote there, notice that you're doing some. There was some. Where was it? There was thread.sleep. Yeah, thread.sleep.
Yes.
Instead of thread.sleep, why aren't we using like async code here? Is there?
We should. No.
Okay.
No, there's no reason. We should be doing this.
Okay.
It's perfectly valid to do this, and that's definitely recommended. I was just lazy, so I started with thread.sleep. This is not the final code that I want to end up with when it comes to the end example of this demo.
One of the things that I will mention though is you said that this was like very like rudimentary or very like sort of not really how you want to test it. But I will say that it's probably a better way than console.log on like JavaScript applications. So I like that.
Yeah. I use so BUnit is a little bit different, and especially because my component has a timer in it that constantly goes. There's no synchronization that I can control from this testing project. But normally, what I would do is if I write a library or whatsoever, I would just implement a console application and just do some manual testing against the library in a console application, which is basically the same as this. We need a BUnit, so we use XUnit application. But at the end of the day, this kind of testing is super useful if you're just prototyping something out, because you can very easily change your code. You can change your happy path. Again, this is my happy path where I go from an initial state to starting state to started state to finish state without issues, without exceptions. And I can just mess around here. I can try to record more hits and see if that works, stuff like that, right? And it's an easy way to test around. But you don't want to have this as your safeguard before deploying to production, because it's unsecure. I mean, you can't repeat tests easily. So that's why I wanted to move on to actually doing unit testing with this.
Yep.
Let's see if we are good on time.
Yeah, go ahead.
We're okay. So let's start. Let's make a first actual test. So I'm just going to copy this code path. And right now, I don't need this. I definitely don't need this. All I need to know is that we start out in the initial state. So I can say equal, and then it's app game state dot initial, and then it's going to be app dot instance state, right? And this one should succeed. So this is my first test, and I just make sure. Let me just write this. This is the first unit test, and I just make sure that we start in the initial state. And if you look in Test Explorer, this one will be happy. Almost. Sorry, I got a little issue here. That's because of this. Just go back to the good old thread sleep. It works. Run this again. Oh, sorry. Wait. Right, and I would assume that it will succeed. And yep, it succeeded. So this should be green light any second now. Whenever you're streaming, everything slows down tremendously. But let's just implement our second test over here. And that is, again, we don't need this. We do need this. We don't need this. And now I want to make sure that I'm in the starting state. Right, I think this is starting new game. Starting state. Right now, my unit tests become well. This is actually proper unit testing. I have individual assertions for expectations of particular states. So in this case, we started out in initial state. In this case, we assumed that this succeeded. We started a new game, and we assume that we end up in the starting state. And I can go on. I can keep adding tests like this, which I've done so over here. So here I have an example is start in initial state, right? And I have a few more assertions on top of this, but basically that's just to enforce the initial state, because a state machine is often not just a state, but also the side effects that it has as part of being that state. So in the initial state, we expect that there's no transition scheduled to the next state. We expect that there are 0 hits and 0 misses. Great. Let's move on to the next test. Again, I render my app. I start a new game, and I expect that we're in the starting state, and I expect that we've scheduled the transition to the next state. Moving on, we have after starting period moved to start state. Okay, this is getting more complicated. So again, I get my context, I render my app component, I configure it, I wait a certain period so that, or I wait a certain time so that the state can have transitioned from starting to started, and then I assert that we're actually in the started state. And also I assert that we actually have a scheduled transition to the next state. Finally, we do again the same thing, so we repeat all of this over here. And then we assert that we're actually in the finished state. So we have now 2 awaits over here. So we wait for the starting state, and then we wait for the started state. Once both have passed, then we assert we're in a finished state. I can go on, because again, there are more tests like this. If after I'm in the finished state, I want to start a new game again, I can do that, and I expect to be back in the starting state, for example. Right? So the pattern that hopefully becomes obvious here is that we had that happy path that we had before, that we're now just repeating. We're repeating it, repeating it, repeating it. And my total, like if I look at the code here, I have 235 lines of test code, even though my component itself is only 150 lines.
Yeah.
And any line of code is a potential bug. So it's sort of just, I don't know, it's repetitive to write unit tests like this.
Yeah.
But we do it for a reason.
So
Yes.
a question there. Speaking of repetition, one of the things that really stands out is this app, right? You assume that every time you're rendering your app component. So we have a question here from Rizwan asking, can we define preconditions and postconditions in BUnit?
Yeah, well, you can. So what you can definitely do is you can, for example, have a help method, right? So instead of doing it this way, I can just extract this. If Visual Studio wants to listen to me today, yeah. Extract method, create app. Right, this is possible. There's a problem with this. Already, like in this case, we had to capture the context, the test context, and this thing is disposable. So we wanted to do this, but this is not possible. Because,
Yeah, and I think a part of that depends on the test framework you're using. Because I think if you use MS Test or some of the other ones, right, like there's startup and shutdown or cleanup or like different types of events you can plug into that will run before and after your test. So kind of like what you said, you could reduce the lines of code for that setup if it's a common setup, or parameterize your setup if you wanted to, based on plug it into some of those events, but that's specific to the test framework.
Absolutely. There's of course limitations to that. So if I look at my manual test over here, note that we really have a happy path here, right? So we had the app, then we want to start a new game. We don't always want to do this. We only want to do this after, like, when we want to test past our initial state. But if we want to test something in our initial state, and we don't want to start a new game, so we don't want to hit this method every time. But then we had to sleep, or task await. How are you gonna generalize that? That's gonna be difficult. It's possible. You can create a new class that you can sort of transition yourself manually, but the more code you add, the more you transition yourself away from this simple implementation that we have over here. Where, again, so what we really want to do here, what I think, is we want to be able to say something like, introduce a test at this stage, right? At this stage in our scenario, because I call this a scenario, in this case it's called the happy path scenario, we want to see if we can inject tests that will test that scenario as it is at that particular stage within the scenario. I hope that makes sense.
Yeah, that makes sense. So you have this particular thing you want to do, and then after this point, like now you want to start actually running the test post setup.
Right. That's correct. So for that, I actually released a project. I'll show you it on GitHub in a minute. But I call scenario tests. So if we bring that into the mix, scenario test of XUnit. Again, I said before, this is only available for XUnit at the moment. I have reasons for that. We can discuss that later on. Let me first show you what it does. So I can install this. That's installed. Now I have to change a few things. So this has to be part of your class. That is because we use source generators to generate additional source code, which injects itself in this class. So this class needs to be partial. This happy path doesn't become a fact anymore, which is XUnit artifact. It becomes a scenario. I call it a scenario. And you have context, so scenario context scenario. Okay. So now if I look at my unit test here, let's start with the first unit test. I had a test here that asserted all these things in the initial state of the application. So let me do this as well here. So I have my app configured. Here's where we start the application. So I want to do this before this. And I can say scenario. Let's introduce a fact here. Start in an initial state. And let's give it an implementation. Right, and this is the first scenario test that we've implemented. So note that we still have our happy path, we still have our scenario, but now we've added a test along the way. And this test is actually interfering or interacting with my application over here, the next state, and we can see that we have 0 hits and 0 misses. And if I downbuild my application, Yep, we have it here. If you were able to see this, let me just add it in the comments. We now have this unit test available to us. Oh, sorry, not this one. Sorry, my bad. That's the wrong one. This one. We have a unit test that is called Happy Path. We start in an initial state. And I can execute that one. I can even put the debugger here. Just gives it a breakpoint. And you can see that I can just test my scenario at the state that it is in at the moment. And let it go. And we're green. So if you can see in the sidebar here, we're green. We have an initial scenario test that succeeds. So let's just introduce another one very quickly. Then I will go to a big sample. We have transitioned to the starting state. Let's give that implementation. And in this case, I just want to equal app game state. Just copy this one. And it should be starting. Right, so we added another test that is happening after this line in our scenario. And again, if you build my application, then you can see it will pop up over in unit tests, and I can also run it. Now, remember before that we have this test over here, we get all these assertions over here, and maybe something is broken here. So maybe this one was incorrectly typed and it had started here instead of initial. Right, so this test is broken, and if I run this test, then I can see in Visual Studio that this is now showing this field. This test is failed. That should probably mean that this test, if this out, should also fail, right? So if I run this one, and you will see that this thing is actually also failed. But why? Because I disabled this. So let me get this one back. If I run it again, now it's green again. So even though we changed this over here, it did not affect the test over here. So why is that? If I put a breakpoint over here and I put a breakpoint over here, and I run this scenario, then we can see that it did not even consider this fact that we've defined over here. So anything that's in this fact, I can just do stuff in this with my code base that like start a new game over here. It might have affected my app, but each test, each fact in scenario test is running in isolation. So doing something here is not going to impact anything for other facts that we have in this scenario, right? And this is really the best of both worlds, because now I can express the scenario, that happy path that I introduced earlier, while adding tests along the way. So I got an implementation here that shows you what I'm talking about. So again, this is the same thing. This is my happy path. I got my context. This is my BUnit context. I render my app components. I do some basic configuration to speed things up. And then I add some tests along the way. So I got a fact here that makes sure that it starts in initial state. I have a fact here that makes sure that scores are getting ignored when in initial state. So if I look at that, I try to record a hit and a miss, but I make sure that those are not being recorded. And I move on in the scenario. I start a new game, and I have additional tests. I have my task delay over here. I have some additional tests. Make sure that we move to the starter state. Make sure that this time we can actually record scores. And then finally we have another delay, so we can move from the starter state to the finish state. And again, we got some final tests over here that is making sure that we're in the finish state. Then I'm making sure that here, if you try to record hits and misses here, that we are not recording them actually. And also another scenario like, hey, what if we start a new game? Then we expect our state to transition again back to the starting state, right? And if I had a test over here, then right now this will still be equal. So game state finished. The studio is really slow today, so finished. Right, and this will still pass. Because again, we did the start new game here, but this is only within this fact. So this did not affect our scenario. So this does not affect code outside of this scenario. And here in this case, we have an example actually of a post condition, right? So this fact will be true for any fact of this assertion will be for any fact that we have over here.
So
this
Koen,
was
let me know.
scenario-
Let me know if
yeah.
I'm thinking about this the right way or not. But so the scenario-based testing, this particular library you're using, it's almost like a different way for us to group tests together. I'm guessing because
Right.
as I'm reading it, it's like you have multiple tests inside of one fact, like
Right.
one X
Right.
unit fact. But then now, like you said, you're able to create those scenario facts on those different lines, and then within the test explorer, you could say, "Hey, I want you to run this specific fact within it." So
Yes.
I'm guessing
Or all
now
of them.
I'm just reusing code within the same block of like function block, pretty much.
So if I do, I think Bekkenutte is called Windows. Yeah, I'm trying to zoom in. I'm not sure if you can see my test explorer because it's on my second screen.
I can see we can see your navigation bar, and now okay, we can see the test explorer.
Yeah, you can see here all my scenario tests, the ones that I have
Okay.
in my code base over here, and I can run them. Oh, nice. I'm not very familiar with this tool. I can run all of them, and all of them will be running. You can see all of them running in isolation. Again, there's this test delay in there. So we wait for like 3-4 seconds in the biggest test that we have, and you can see that being simulated here. So we have each test, and each test is running in isolation. So I can also take one of these and run them individually, or I can take one of them and debug them individually. But each of these tests, they do not affect each other. And that's, I think, key. Yeah, that's important to remember.
So we have a question here from Victor.
Yes.
You have a significant amount of tests, and I imagine this takes some time. So the question is, can we run BUnit tests in parallel?
We can. So in BUnit, I think you can run them in parallel. I have to say I'm not an expert on BUnit, so you may have to double check this. Scenario tests, however, at the moment, the current version, they do not run in parallel. There's nothing stopping them from running in parallel. It's just the current restriction in code, because the current version is sorting the test execution ordering in X units. That means that this fact will run before this fact. And because of the sorting, it also makes sure that it's single-threaded. Again, this is something that we can easily change in the library. This library scenario tests is new. It's not in a final stage yet. It's almost ready for public release. Like you can use it yourself already. It's in beta release. Right now the version is 0.6.1. And one of the limitations indeed is that tests are not running in parallel, although there's nothing restricting them from running in parallel.
Got it. And then we have a quick question coming in from YouTube, and this person is asking, do these tests work with components that need like services from DI? And
Absolutely.
I'm guessing, for instance, on line 19, whenever you're creating the app, I'm guessing you've already run the pipeline, like you've already registered everything at that point. So now all of your components, like your Razor components or Blazor components, would have already had the things that they need to function.
Correct. So this again is using BUnit. BUnit is an internal pipeline, I would assume. But if I look at the GitHub project, if I can pull one up very quickly, I should have additional examples over here that will shows how you can interact with your services. But here, for example, we have a scenario where we create a database, right? And database is complicated. There's more than just your DI. There's other stuff going on as well. If I was to give an example in the code, and yeah, you can definitely do a service provider here and add stuff to it. And then, I don't know, so add something in a build service provider. Again, I don't have the right code in here. But now you can use a service provider in your scenarios. So yeah, this is basically your preconditions or your initial code, and then your fact is running over here. And then finally, we can have post conditions.
Got it. Because like when I write tests, I usually think about tests like the way that you did it the first time, and you had like arrange active cert. At least when we talk about unit tests, right? Like we usually have a similar pattern. So what you're doing here, like if I'm trying to map my brain to how you're having it here, like that whole everything above your scenarios are like your arrange, right? And then you're acting a service inside of each one of those facts, right?
Almost.
Like
that's almost correct. So indeed, this is my range, and here I'm doing my insertion. This is also my act. in this case. So I got my arrange and my act here. My assertion is basically just telling me, okay, at this point in the scenario, right after line 22, I'm going to assert that this is true about the scenario. And then I'm going to quit. Like, I'm not going to call any of this. Of course, like going down the scenario, we transition our scenario, right? We progress our scenario to the next stage. So we have an initial scenario, we move our scenario to the next stage, which is the starting state of the game. And then we're at this stage of our scenario, and we're going to add a bunch of other assertions to make sure that we're happy with what our scenario looks like at the moment.
Okay, so in terms of like just the flow of the code, so let's say I wanted to run your scenario that was on line 44, right? So the scenario moving to a starting state. So it'll run all the code above that. It won't execute those tests that are on 24 and 31, but it will run the code that's on line 42, which says app.instance.start game. So that now would be another act, I'm guessing, right? And then
that's right.
The fact you run your assertions.
Let's try. So if I go to that, calls move to a starting state. Let's see, move to a starting state. Let's debug this and just see what happens.
Yeah, because one of the reasons I'm asking too, because while your debugging gets setting up, is wondering like why wouldn't we or why couldn't we have done line 42 inside the fact? Is it just bad practice, or is there a particular reason why we don't want to manipulate application states inside of a fact?
Oh, we can. There's nothing stopping us from doing that. And that's
so you could have moved line 42 into the scenario, and then it would have been fine.
Yep, absolutely. So the reason I'm not doing that is, let me just quickly abort this. The reason I'm not doing this is I want to transition our entire scenario. Right? So
like the entire function. Like the entire
function. Like I want all the facts after this to have had this line called. Right? But we can perfectly, for example, move in the starter state. So after we move to the starter state, let me introduce another fact that says we can restart the game. And if I, this, then I'm gonna do a app.instance function intelligence, start new game. So we're in the starter state, and I'm gonna call start new game. And now I'm gonna assume or assert that the current state is going to be the starting state again. So inside that test, I can perfectly modify our application. When it comes to this line, it will never run this. Because for this fact, for example, it's not going to run this. So it's not going to it's going to call the start new game, and it's never going to manipulate the state. So we can manipulate the states in our facts if it is useful for us for testing. And whatever we do in these facts is isolated. Whatever we do outside of these facts is not isolated, is shared.
Okay, so, and I'm sorry, because I have like so many questions. So when you look at how if I was supposed to move line 42 inside of one of the facts, hypothetically, right? And the fact that the facts don't run sequential or asynchronously, what would happen if, for instance, I said within, for instance, moving to a starting state? What if inside of there we said, end game or something like that? Like it changed the state of the game. What would happen to the next thing that's after that? Like, would it reset it? You know what I mean? Like, would it reset the app state if I'm running in a different scenario, or would it just be whatever happened after the fact that ran before? Does that make sense?
Absolutely. So, first of all, let me show you that through the debugger. Then you can see what's happening then, and then I'll show you what's happening behind the scenes, and that hopefully will explain what's going on there.
Okay.
So first one, the debugger. What I'm debugging at the moment is if I look at my scenario, so I get this scenario argument. If I look at this, I can see that I have my target name. And my target name is moved to a starting state.
Yeah.
That's my target name. So, okay, I'm going to run this. I'm going to come on the defaults. Okay, here's my first fact. Let me put a breakpoint here.
Mm-hmm.
Inside the fact, and let's see what happens. So I press F10, and it skipped this one. Right? It didn't enter this one, it skipped it.
Yeah.
Same for the next one. It's going to skip this. Now it's going to transition my scenario. It's going to start the game. Now I'm going to put the breakpoint here. Press F10, and now it's hitting this code. Again, because this is the target that we're hitting at the moment. Move to the starting state. Right? And now I can do my assertions. I can manipulate. Okay, I got a failure here. Why I got a failure, I don't know. I have been changing my app, so it's ready. Okay, because the time is still running in the background, the app is already finished at this stage because I have a debug on, and the debug is slowing down time. So this now failed, and that means that this test is still failed. But that's again, if this was fail legitimately, like I wasn't debugging it, it just had a bug in my code, or this was to manipulate the state of our app, that would not affect any of the other tests. It would not affect any of the other outcomes. And the reason for that is, so if I look at the code that gets generated for this, that is, you can see it over here. Yeah, sure. So I got all these calls to scenario that fact, and each call is generating a test harness, which is actually like XUnit fact that we implement. Instead of calling it the XUnit fact, we call it the scenario fact, which is like it customizes XUnit internally a little bit to make the things that we do here work. But at the end of the day, these are just individual unit tests. So we got a unit test here. Happy part starts in initial state, and this is calling our scenario, our happy path method. Because happy path scores are getting ignored when in initial state. This again will call our happy path. So each fact that we express in our code is just going to rerun this happy path and then only target the fact that it should target.
Okay.
I hope that makes sense.
Yeah, it makes sense. Because I think the thing what I was trying to sort through in my head was, is it capturing the state of like everything outside of the fact? You know what I mean? Or is it just capturing whatever's in it at that moment? Because in some situations, as you see here, like you have that app instance, and in some of the facts, like, you know, if you change the state and they're running sequentially, right? They're not running asynchronously. You know, if my fact runs before your fact and your fact changes the state, right, to finished or whatever, because again, we're capturing the instance, right? And the app instance is not created in the fact, it's created on the outside. If you change the state, does that mean that any sequential or any following facts? I feel like facts is such an overloaded term. I'm sorry. If any following facts would just have like that changed state in there, or would it just be like, hey, I only have whatever the snapshot of app instance is, and not whatever else was changed inside of any previous facts that ran before me?
Right. So in this particular example, because remember over here, for each generated unit test that we have, we're just calling this method happy path.
Yeah.
Right. And in this happy path, right at the start of the method, we create a new app instance. So because we're calling this method multiple times, we create multiple app instances, and each fact does not share the same instance. Of course, we could do sharing of instances. It's perfectly valid.
Yeah, that was
if you want to.
Yes. David Pine asked here. Let me see. Yeah, so about capturing the app instance inside of the Lambda closures, would it make sense to have that parameter in the scenario helper instead? That way you're able to capture that sort of app instance throughout your facts, or your, I guess the facts inside of your happy path fact.
That's let me just digest this question 1 second. Would it make some sense to have it as parameter?
And David, feel free to clarify that in case I butchered it.
Yeah, so that's definitely an option. So if you're using XUnit, for example, you can use, I think it's called fixtures, test fixture and class fixtures. And I've been doing that as well. Like in some cases, we want to use fixtures and then share, for example, database that we create. Like, for example, I have scenarios where I create a database in a Docker container at the start of the test, especially when you do integration testing or end-to-end testing. And you want to make sure that everything flows correctly. You want to share the database. You only want to create a database container once and then have facts reuse it. So there are configurations on my scenario that I can give it. So, for example, over here, I have a property run in isolation, which I can turn off. If I turn it off, and I have to warn you, this is still in preview functionality. But if I turn it off, then that isolation feature that we talked about before does not happen anymore. So each fact will run for this app, for this test case.
In that case, behind the scenes, does it just run one instance of the of the class and run all the facts like sequentially?
That's what's getting added at the moment. So I would say at the moment, again, do not try this feature because it's not ready yet. That's the intent.
Right.
At the moment, it will basically just still execute this happy path for all your unit tests, but it will not skip facts that are not relevant for the generated unit test. But the end goal is indeed that like you plug this in and you can just run this once and it will run all the facts. It will just run happy path once and it will just run all the facts and report them individually as test cases. But that's at the moment not well supported, so I would say stay away from that. If you want to share state, you can use in XUnit fixtures, so class fixtures or collection fixtures, and that will help you to share state. And let's see, yeah. So I also have, of course, because this is XUnit, and XUnit has basically, I would say, two types of facts. So you got your normal facts and you got your theories, right? And we have the same thing here. So we can just have a theory here that says we can hit numerous times. And the way we implement the theory in XUnit normally is we would have, let's see, I got some here. Like we got a data source. So in this case, we got some inline data, but this data could come from a class method or from a CSV file. We got some inline data, and we can execute this theory here multiple times, in this case 5 times, and each time we get passed in the next argument that we have in our data. And then again, we do the same. We have a range, act, we have a delay, and then we try to generate that number of hits, and then we make sure that we recorded that number of hits. Right? This is how we do it normally in XUnit. Again, a lot of repetition here. Let's see how we do the scenario tests. So you just use code. So I got my samples, just defined as an array, useful, and I just have a for each. For each hit sample and samples, and then we have a theory here we can hit numerous times. I give it an identifier, so the identifier is something that we can read and also something that uniquely identifies this test case. And I invoke my test or my fact on this this scenario. So if I look at how that looks like in my code or in my unit testing, you can see here that we can hit numerous times selected, and I got 5 cases. We can hit 0 times, 1 time, 10 times, 50 times, 100 times. Right, and again, this also, because here we, for example, call app.instance to record hit, right? So if we have a first case, record a hit, now we should have 1 hit in the application, which is correct over here. But then when we come to the 10th case, and we call app.instance to record hit 10 times, well, if we had that first hit already recorded, then that will fail. But again, theories, they will also run in isolation. So they will also not make sure that each one of these cases does not get impacted by the other cases, because each time it will run into isolation. I hope that makes sense as well.
Yeah, that makes a lot more sense. I think for me, it was good to see that generated code. So now I could be like, oh, okay, this is what this is really doing in the background.
Right. So the way this theory is working code is really just, okay, it finds, hey, I got a theory here. I got an identifier. I'm going to see if I have this identifier in my history list. If not, I'm going to run this test case. And I'm just going to run the scenario again. So I'm going to replay this method again. And I got my first theory. I can see, hey, I read this identifier already in my history list. So I'm going to skip it. I got another theory instance. Okay, now I can execute that one, save it, and rerun the scenario again. So it's all about really implementing the initial scenario and just adding the tests along the way. That's really the intent here.
Quick question on the generated code there. Did it use source generators, or how is the individual tests or scenarios generated?
So this is decorated. So these tests that are getting generated is decorated with a scenario fact attribute. Scenario fact itself is I can go to implementation. Oh, I can't, because let me see if I can open the source code of this project. This is also a reason why it's only available for XUnit at the moment. There's internals that we have to plumb into. So I've only done it for XUnit at the moment. And second of all, the terminology here is fact and theory, which is very much XUnit specific. MS test has I think is test, and I'm not sure what the equivalent of theory is. And I'm sure NUnit has names for this. So that's why at the moment we just have XUnit version. But I'm happy to discuss how to develop other versions. if I look at my code for this, and I look at the attribute, I got my scenario effect attribute, which again just extends the XUnit effect attribute. Right, so we got XUnit as effect attribute, which is what you would normally have on your code. So I click tournament in my non-scenario test. I got these effect attributes on my methods, but in the generated code, I just have my scenario effect attributes. And the reason why we do this is, first of all, we want to record more information. So if we want to map the source code, so we want to know that, hey, this test, the actual code, lives within the scenario file, on this file and on this line number, which means that if I go to Visual Studio, I go to my test explorer, and I click on any of these tests, then it will bring me directly to the source code of where those tests live, which is this, for example. We also use this to have a custom test runner in XUnit. And this, again, is very XUnit specific, but this enables the logic that we have. So I won't really go through this code because it's getting quite complicated and XUnity specific, so I don't want to go too much into detail. But yeah, the reason we are having these scenario effects on here, and that will tell us to use the scenario effect runner, which is a little bit different than default XUnit test runner. But at the end of the day, it allows you to do this, which is where it adds value. Are there questions at this stage?
There was one that our friend Jose brought up, and I don't know if you're familiar with C# coroutines.
I am familiar with coroutines, C# coroutines.
Yeah.
So Jose points out that using task delay may vary depending on the machine. So would C# coroutines fit well in this test scenario instead of using task delay? He points out that that's how it's done in Unity.
To be fair, I know coroutines C#. I think you use like a... I'm not sure anymore. I did Unity a long time ago. I wouldn't directly know the answer to the question, but I would bet you yes. I can't say that for sure, but yeah, again, this is just executing a normal method. So whatever you can do with XUnit over here, whatever your limitation you throw on top of it, like in this case using bunit, you're confined to that. But apart from that, this is just a method. So this is now async, but this could perfectly be void and synchronous. And I can do, I can call another method in here, in which I have, so I can perfectly have a helper method here, or a helper. It takes my scenario context. Scenario. And in here, I can also express facts. I'd say if I wanted to do this. And doing it this way, now I can just call my helper in here and just pass my scenario. If this was a, I think, a coroutine, you would write, I think, enumerator. So this is what it is. So I could do this here and then probably do like to list or something like that to invoke it. Again, I'm not too much into the details, but there's a good chance that it's possible. Because again, this is just normal C#. There's nothing that magical going on under the hoods. We just invoke this happy path for each individual fact or theory case that we have.
Awesome. Well, hey, Koen, it's been absolutely amazing having you on. We're just about out of time, but before we cut off, I know folks are going to want to know, where can I get the code? Where can I see the samples? Do you have like this particular game up GitHub anywhere that we could share with folks?
Yes. So very quickly, I just want to show you, like, you can look at it at home, but there's also an end-to-end test demo over here that also uses scenario tests, and in this case is using Playwright to go with a scenario like, hey, we start the browser, we transition the page, and along the way we test facts about the page. So definitely worth a look at. Well, the code itself, you can get it. So the project itself is scenario tests. So there's a GitHub link, Koen, and then my name /scenario test. I'm sure we will share the links somewhere in the chat. So that's one option. The second option, I need to quickly, let's see if I can pull that one up. Yeah, it's over here. So it's also on GitHub. So the demo that you saw today is also on GitHub, and it's called Click Tournament. So in reference to Unreal Tournament, it's called Click Tournament. And here you can see the source code of the application itself that I showed you earlier. We have a manual test, which is like an initial approach of how you can do testing, in which I start to introduce scenario tests. And then we got the actual test project that has a non-scenario test version, which is just your basic unit testing that you did before, and an equivalent or almost equivalent version that actually embraces scenario tests. So you can compare the two. And finally, over here, we also have that end-to-end test implementation that we have here, over here, which is using Playwright. So if you're interested in that, you can also see how this is being implemented. For example, here you can see that we can skip scenarios if our web server is not reachable at the moment. So we can skip the execution of scenarios, and we can report the scenario skipped if our web server is not available.
Awesome. Got it. All right. Well, again, Koen, really appreciate it, man. I definitely want to go and dig through some of this code and try it out myself. I'm big into testing too, so that's why I had so many questions. I hope you didn't mind me hammering you with some of those questions.
I just want to quickly note one tiny thing here. It's just important to note that this is, as I said before, I'm using it in production in many projects already, but I am still version 0.6.1, and I would really like your input. Like if you have questions or you have concerns, or you want to add features, just hit me up on the GitHub and open up issues. And this is definitely useful in production, but be aware that this is not a version 1 yet. It's still version 0.6.1.
And also on GitHub, like you mentioned, so folks could always submit issues and give you feedback and let you know what their experience is like as they're working with your project. So that's always
that would be great. Yes.
Awesome. Well, awesome. Koen, again, thank you so much for being on. Thank everyone that's still here. Thank you all so much for watching the show. Definitely make sure you check out some of the recordings. We have them available on YouTube, and you can definitely check out .NET-Docs.dev. You can check out our website. We can see the schedule, any upcoming shows. And again, you can see links to past shows as well. Now, I think in the next couple of weeks, we have some more great content that's going to be coming up. We're going to have Isaac Abraham. He's one of our MVPs. We're going to be talking about F#. And then we're going to also have Don Sign on as well in a couple of weeks as well, doing an F# AMA. So definitely stay tuned for that. Thank you all for watching. Koen, thank you again for being here. And
my pleasure.
Make sure you come back and watch some more .NET Doc shows.
Sure thing.
Thanks for watching.
See you, folks.